Let's compute the so-called differential. In Calculus 1, we talked about differentials in terms of a function that depended upon a single variable. F depended on x. We talked about dx and dy as being differentials, where delta x and delta y were the so-called increments. But what if you have a function that depends on two variables, where z, which is f of x, y, depends on x and y? So we call the difference, if we could actually calculate it, which we can, the difference between the function value as it's expanded with x plus delta x and y plus delta y minus f of x, y is called the increment. The differential here, dz, is called a total differential to distinguish between dx and dy. The total differential depends on the partial derivatives of z with respect to x dx plus the partial of z with respect to y dy. So the problems will ask for the increment or and sometimes it will ask for the total differential. Here this problem asks for the total differential. Let's write z as the negative times x squared plus y squared. That's raised to the negative first power. The total differential involves the partial derivative, so let's go ahead and find the partial of z with respect to x. So this becomes negative times a negative is positive out front, times x squared plus y squared to the negative 1 minus 1, the negative second power, times the derivative of the inside with respect to x, that's 2x. So here we have 2x over x squared plus y squared to the second power. Likewise, the partial of z with respect to y would be 2y all over x squared plus y squared to the second. So then the total differential, dz, is the partial of z with respect to x, which there we got 2x over x squared plus y squared, is raised to the second, times dx, plus the partial of z with respect to y, so there that's 2y over x squared plus y squared, raised to the second, times dy. That's all it's asking for there. Secondly, let's look at a problem where they want you to compare the increment with the total differential. So for part A, it says find f of 2 comma 1. So this is 16 minus 2 squared, which is 4, minus 1 squared, which is 1. So here we get 11. And find f of, here's the increment displacement, 2.1 comma 1.05. And so this gives us, I heard my phone go off, 16 minus 2.1 to be squared minus 1.05 to be squared. And that gives us, when you calculate that, 10.4875. And then it says calculate the increment, dz. This is the increment. So the increment is said to be f of x plus delta x comma y plus delta y minus f of x y. Now, do you understand here that x is equal to 2 for this problem? Y is equal to 1. Delta x is 0.1 and delta y is 0.05. So the increment that you're looking for is this f of 2.1 comma 1.05 minus f of 2 comma 1, which, so you found that already. So this would be 10.4875 minus 11. So you get for the increment that difference is negative 0.5125. Now for part B, it says compare, find the total differential, and use that to approximate, to compare with the increment. So the total differential, dz, has the formula of the partial of z with respect to x dx plus the partial of z with respect to y dy. And where we compare the dx is being approximated by delta x and the dy is being approximated by the delta y. So those partials, the partial of z with respect to x, where's the function? This guy right here. So this partial of z with respect to x is negative 2x, and the partial of z with respect to y is negative 2y. So here we have negative 2x times delta x minus 2y times delta y. You can plug in the values. This is negative 2, x is said to be 2, delta x is 0.1 minus 2 times y is given to be 1, and delta y is given to be 0.05. Now when you calculate that, this is dz, excuse me. So you get dz, and that comes out to be negative 0.5. So you compare the increment, which came out to be negative 0.5125, with the total differential dz, which is negative 0.5. Very similar.